Hello and welcome back to a brand new video. So in today's video we're going to be looking at creating a Lexer. Now when I say Alexa I mean a Lexer, not the Amazon device. So for those of you who aren't familiar with what Alexa is, you can look at the bottom of the screen to see how I'm pronouncing it as well. So it's Lexer. Alexa is effectively a tool that allows us to break down input into tokens. Now you almost do this instinctively when you read. So you have a sentence in front of you, you can break down that input into words and commas, full stops, wherever it may be. And in the field of computer science, we can do that when creating a programming language as well. So our input, for example, let a equal 5, semicolon, we can break that down into let, which is a keyword, a, which is a literal, equals, which is the assign operator, 5, which is an integer, and then a semicolon then, which is effectively signifying the end of that line. Now, or the end of that section. Now, I'm not an expert programmer, so if you've clicked on this video hoping for a detailed guide about how Lexers work, I would strongly encourage you to find someone else. But what I can promise you is that I'm going to learn how to build a Lexer in this series. Again, this is episode 1 where we're just going to get into the basics. And hopefully you can learn along with me. Now, hopefully this series won't take too long, but we'll see. So it's probably best that I show you. In fact, I'm just going to set up the header file. Now, I don't know if this is something I did mention, but effectively I'm following Thorsten Bell's book, Writing an Interpreter in Go. And, you know, I would effectively strongly encourage you all to read that book. I don't see any harm that could come of that, and I think that doing so you'll probably learn a lot more than you will from this video. So certainly look at buying that book, because that is the guide effectively that I'm going to be using. I'm also using a new keyboard, so you're gonna have to be patient with me because I'm going to make a lot of spelling mistakes, but I'm getting better now to the point where I'm happy to use it in a video. Right, so the first thing I'm doing then is creating a header file. Okay, now in the book he creates a token.go file. And in this section, okay, all I need to do is effectively set up a struct, which is going to be taken in token type. And I need to set up a enum, which is going to store all of our token names. Okay, so illegal, end of file, identifier, int, assign, plus so on. We're going to get that set up right now. Now, there's a few things we're going to do and add to this file afterwards. There is a online example which I have found. There's one on Geeks for Geeks, which is just absolute slop. But there is one that I've seen online which effectively uses the Google test framework. For those of you who aren't familiar with unit testing, we're going to need to do a bit of that in this project as well. So that's partly why this project is quite nice for us. So the first thing I'm going to do is type def, and then we're going to do enum. And then, first time I've actually used enums in this video, by the way, so hopefully it'll all go well. But anyway, so the first thing we're going to do is illegal, or token type illegal is probably the best way, just so we know. So token type, and then we'll do illegal. Okay, and I'm just going to copy this and try and save as much time as I can. You may want to skip if you are not interested in watching me type in a bunch of stuff. So we're going to have token type illegal, token type EOF, which is end of file, token type identifier, token type in, token type assign, and plus. We're going to have comma and semicolon, left paren, left brace, right brace, function, and let. Now this looks very messy at the moment. I do understand that, but it's fine. We'll deal with that now shortly. So let's get EOF in here then first. Get that in EOF. And then the next one, which will be, I'll try and keep the comments in there as it is in the book. But I can't promise that. So this is something, by the way, that I've been planning about doing for a while. It's something that I tried actually doing myself a while ago, but I just didn't really I didn't feel ready for it. There was a lot of stuff that I didn't really understand at the time. So I thought now would be a good time to take on this sort of project. So we'll give it a go and see where we get with it. There's no doubt that I'm going to have to See, this is the bit that, you know, this new keyboard is, I do apologize, you have to bear with me. So we got assign, we need plus. So these are going to be all the tokens. Now, obviously, there's a lot more that we could add, and we're not going to add too many in here. Okay, we're just going to do the basics. So we're going to add in comma. Oops, plums. Okay, that's not good. For Pete's sake. Yeah, this is not going to go well. Right, comma. We need to do semicolon. Okay. Next, we're going to do lparen. And right paren. I think I might have added too many in actually. We're going to add left brace. And right brace. Yeah, we've got one more, too many in. Yeah, but if any of you have created Alexa before, you know, by all means, let me know, and we can maybe add more to this as we go along, or make corrections. It's not going to be right the first time, but again, that's what the whole learning experience is: trying things, testing them, seeing if they work. If they don't, that's fine. We'll figure it out as we go along. Again, you don't have to be a genius to do this stuff. At least I hope you don't, because I'm really, really going to struggle then. Right, so we're going to name this then. Oops, we're going to name this token type, and that should be it. So hopefully I won't get any errors from this. Again, first time using an enum and seeing it happens to be, we're going to worry about that after. Undetermined conditional directive. So I've been playing around with my LSP. So something that I was doing before making this video is playing around with this sort of stuff. And we're going to have to do a few things, which is going to be exciting actually for this project. It's stuff that I want to learn anyway. We're going to have to learn how to use CMake. We're going to have to learn how to effectively, because NeoVim doesn't have, effectively the issues that I was having is I was trying to use Google Test, but I was getting a lot of errors in my Google Test file. And the reason for that is that the LSP couldn't pick up all of the flags, all of the files, I think, inside that particular C++ file, because I don't know if I mentioned, but Google Test is a C++ framework. So in effect, this is something that we needed to do and figure out. And I feel like there's a lot to learn there. So we need to do that. We need to do unit testing. I don't know what I'm doing here. Typedef, struct, and we're going to call this token, and then we'll do this. Okay, so token then is a structure which is going to take in two types, or two things. It's going to take a token type, which is the enum we just created, and we're going to call that type, and it's going to take in a char array, which is going to be of type, well, is going to be called literal. Okay, now we're not going to use that much in here, and we'll talk about that later. So actually, something that I'm going to do is call this. Now, again, you probably heard me mention earlier that there's an example online that I'm kind of following as best I can. I don't have it in front of me. Again, this is something that I'm trying to do naturally. But he uses, or she uses, could be a she, S token when they're creating the token, and they just simply call it token, then typedef. Now, why they do that, I don't know. It's above my head, really. It's just making mistakes, no sloppy mistakes. But effectively, I imagine it's because obviously typedef makes things much cleaner. So again, I think there was a reason. I figured it out, but it's just gone up my head. So in effect, we're going to be using, following the same kind of method. So we'll call this token, and that is that done. Now, I think that's all we need for this stage. Okay, so that's our Lexer.h file complete. Now, there's an error at the top. I'm going to ignore that for now. In terms of prerequisites, if some of you want to kind of follow along exactly with what I'm doing, you can use NeoVim, and you can use Kickstart, which is effectively a, if you're not familiar with NeoVim, it's quite nice in terms of productivity. You know, it's easier to just create files, get out the files, search for things. At least I find anyway. So it's quite handy, so I'd encourage you to do it. You can see at the top of there, but sorry, go back to that, I'm jumping from point to point. Prerequisites, if you want to follow along with exactly what I'm doing, I'm using Ghosty as my terminal emulator on a MacBook, and I'm using Kickstart near Vim then. And I don't think I've made many changes to the config file that it came with. So you're more than welcome to follow along exactly if you're beginning and just want to get familiar with this. But you don't have to. You can use Visual Studio, whatever you prefer. You can see at the top then that I've got my .c file, Lexer.c. Now I'm going to have to go into this because we're going to jump onto the next part, which is we're going to ignore the testing part for now. That's the last part that we're going to do, okay? So that's something we're going to look at in another video, okay? We'll probably do a full video on that because I want to get familiar with how to effectively use Google Tests, because I feel like that's a very important skill to have. Unit testing is very important in the industry. I know there's different ways about going about it, okay, but unit testing is seen to be very useful. So we'll come back to that in a separate video. So sorry, I'm getting distracted. Jump here from page to page and task to task. Right. Next thing we're going to do then is create our main file, which is going to have all of the helper functions in there then. So we're going to need to use, trying to think what libraries we're going to need. We're going to need the regular ones really that we've used in previous videos. So we're going to use, trying to think, std. Okay, I don't know why it's not auto-completing when I use my less than, greater than symbols, but that's fine. We'll work around that. So we need std input output. Okay. We're also going to need what else we need? Include std lib, I believe. So std library, std library.h, and what am I doing? See, this is trying to get used to the keys on the new keyboard. Anyway, so we're going to use stdio, stdlib. We're going to use string as well, but I think that'll be later on, so we won't need it just yet, but we're going to include it. And there's going to be one more, but I'm going to forget about it. Actually, no, I'm not going to forget about it. It's more important, actually, so we'll use it now. Standard int.h, okay, because we're going to use size t, which I've done a little bit of reading up on, and I'll try and explain as best I can why it is we need that. But before I do that, of course, let's create our next structure. So next struct, we're going to use typedef. Again, of course, we're going to use that as much as we can. And then we're going to use struct, and we're going to call this Lexer. So struct Lexer. And what we're going to do here is we're going to put through our input. It's backwards. See, I'm reading the book. This is the difficulty of creating a Lexer in a different language, and the only resource you have is this book. Because Go is a very similar language to C, but there's some things that are slightly backwards. So we're going to use char. We're going to use const. Oops. See, I'm jumping around now. Const char array. And we're going to call this input then. Okay, so that's the first one. The next one we're going to need is actually input. So we're going to have int, or size t, sorry, because that's what we need to get familiar with using. And I'll try and explain why later on. So we're going to call this input length. And again, I'll try and explain that. Or input length, maybe that would be better. I think that looks a bit better, so we'll keep it at that. We're also going to need position. So size underscore t position. We're going to need size underscore read position, I believe. Yep, size underscore t read position. For those of you who may be getting frustrated as well that I'm not using tab to kind of autocomplete, it's because I can't, and it's something I haven't bothered fixing. So I should probably just turn the LSP off. In all honesty, but I guess it can help spot errors in some sense. So we'll keep it on for now. And the last one then is just simply going to be char, and it's going to be, we're going to call this char or ch. Right, so I'm going to try and explain these as best I can. Okay, so I haven't really explained in great depth what a lexer is yet. Okay, and there's a number of reasons for that. Partly because I'm doing this off the cuff, which is quite difficult to do, so it's not very planned. So again, sorry about that. But effectively, we need to take in our input, which again is going to be our line of code. In this case, we need to use input length because, and I forget the reason for that, but right again, I'm kind of going off somebody else's example off the top of my head, but I believe the reason is because we don't have, like for example in Go, if I just go ahead in the book, they have a function len, so you can take the length for the input inside a struct. We can't do that because C doesn't have those luxuries, so we'd have to create the function to do that. But instead we're just going to call that a field in our struct, and we'll assign the value after. Okay, so let's go back to this then. So we need to create a lexer. So let's see if I can do this right off the top of it. Let's just see if we haven't got any errors here first. Okay, we have, because we haven't included this. So let's call it token. Yeah, just call it token. And something we haven't done as well actually is include our header file, which is something we must do. So let's do that now. Include, and then again I have to look at my keyboard for certain things. Lexer.h. Again, see, tab doesn't work, it's awful. Right, now hopefully I don't get an error with this. Yes, I will, because I should have included something at the bottom, which is fine for now. We're going to ignore that. So sorry if that bothers you, but we're going to ignore it. We'll come back and do that maybe to start the next episode. Right, so first thing we need to do is create the lexer, which is going to be our new function. So we're going to call it, I believe it's just going to be a void. We're going to return a lexer. So I just realized I called it token as a lexer, right? Okay, well done spotting that, I suppose, until after the video, when half the time when I make a mistake, I realize I make the mistake after when I'm recording the video, so it's frustrating sometimes, but we'll just forget about that. Right, so we are going to return a lexer, and it's going to be called new, this particular function. Oops, new, and inside new we are going to take in the input, which I believe I can just call const char input, so that should be fine. Okay, so I don't know whether to leave this just for a second, and we'll come back to that. It's probably the best thing to do, because what I really wanted to do is to create the first helper function. In fact, I don't know whether, right, okay, we're going to fill this out, but chances are I could be wrong. So the first thing we have to do, okay, as I understand it, is use memset. Now this is my first time, never used memset before, but effectively what it does is set all of those values in our struct to null. So it effectively gives us a clean start. It's equivalent to when we create a head of a linked list, we set the first value to null, the head of our list to null before we actually initialize it. So we're going to do the same, or at least attempt to do the same. So the first thing I need to do is create size underscore t, and this is probably a good time for me to explain why we use size underscore t, at least to the best I can with the current knowledge that I have. So we're going to use size underscore t, we're going to call it length, and we are going to assign, what are we going to assign to that? Size of, and then we're going to do size of the input. I believe that's fine. Let's just double check I'm in error. Yep, that's fine. Right, okay, so the reason why we use size t then, and again this is to the best of my knowledge, is because when we're dealing with strings, it's more of like an optimization thing. I think we could get away with using int, it would work fine, but when we deal with strings, it converts them into type size underscore t. Now another reason why we want to do this is I think in mem set, which is what we're going to use shortly. In fact, let me just do this really quickly. So we're going to do, let's create a lexer, and we're going to call it just L. I believe that's what they use in the book. We'll just double check. use L, so we're just going to stick with that. We're going to do L equals malloc, and then it's just going to be simple, which is going to set the size of that to whatever the length is, and I believe that's fine. Now, this is where we use memset, and you can see memset takes in a void pointer. We're going to use L for that. No, we're going to use L for that. We're going to set everything to 0, which is going to be the int value, and then length then is going to be on the end, I believe. So let's do that now. So we'll do L 0 and then length. Now let's just double check. Oops, I haven't done that wrong. Okay, right, okay. So I've not included the right library there then for that. So what library does that belong to? Does it say? Oh, have I done it wrong? See, that's frustrating as well. I have to zoom out that far. Okay. I believe it's because I've not... Have I typed in something wrong? Or does it... No, I think that's right. That should be right in theory. I think I've just not included the right library. So I'm going to double check what that is now. Now, would there be a simple way of doing that? Let's try and troubleshoot live on camera. So I'll give him a best go. If not, I'll have to have a little look. So if I do man memset, I click enter, string.h. Did I include string.h? And I didn't know. Right, okay, that's interesting. Okay, so let's go back up then. Let's go here. Let's just add it somewhere over here. Include string.h. I hope it's not frustrating everyone that I can't type, but it's something we have to deal with, unfortunately. Right, okay. So now if I click escape, okay, we haven't got the issue. Okay, and we won't worry about that header file just for now. Okay, that's something we'll worry about after. Okay, so effectively what we've done is set all the values in our struct Lexer to null. Okay, that's quite handy. I think it's more of like again, it's more of a safety feature rather than anything. I think I could have just left that. I didn't need to do that. But what we have to do now is set all the values in our list, in our struct. Sorry. So let's do that now. So we're going to do L. We'll leave the input. In fact, I don't even know if I need to set that to null. Don't think I do. Oh no, input. Sorry. I'm getting confused now. Input, we are going to set to whatever the input is being passed through when we create the Lexer. We want to do L input length. Is going to equal the... Okay, what's that going to equal? It's going to equal the... Sorry, 2 seconds. Right, everything's fine. Just wanted to double check I was recording. Input length is just going to be set to length, I think. And then the position is going to be set to 0. Oops. Where is equals? There it is. Set to 0. And then L read position. Let's have a look what's left. Read position. It's also going to be set to 0. Now I think with char we can just leave. We don't need to do anything with it, but again I might come back to that later and we'll worry about that after. Right, okay, so I'm going to try and talk about each of those fields actually. I don't think I explained them as well. So const char input, that's going to be the input. The input length is effectively just an additional field to work out wherever the length is of the input, of course, which we've done further up there, size of input. I believe that should be fine. And then we have position. Now position in the book, it gives a comment, which I said I was going to include the comments in, but I didn't, so let's do that now. So position is quite literally the current position in input. Okay, so that is us examining whatever the current position is in the input. So if it's, for example, the first character or the first whatever it's going to be, we're just going to say character for now. We're going to be dealing with characters. We won't be dealing with words or like keywords at the moment. Okay, maybe we'll add that in later, but for now let's just get the basics done. So current position is going to be, of course, whatever the first value is, and read position is going to be the position ahead of that. Okay, so the current read position, and we're going to create a peak char function later, which will allow us to do that. And the reason why we need to do that is because if we were going to add in, for example, not equal to, or even a literal or an integer, you know, for example, if I was to say not equal to, that is bang, or the exclamation mark, equals. Now, in order, you know, how do we know we're not just using a bang? You know, effectively we need to peek ahead to make sure that there's no equal sign. Otherwise, we're going to interpret the token completely different either way. Okay. So after the current char, I don't know if this is necessary for me to do this, but I'll add it in just for you guys. After the current char. Okay, now this is something as well, if you want me to upload it on GitHub, something I can certainly do. But again, there are other people's, you know, Lexers out there. But, you know, I know some people like to have a copy of things, so that's fine. Right, what are we going to do then? Okay, byte is the current char under examination. Okay, so that's fine. So that's done, and I think we're going to leave that there for now. There's a chance that I may have left something out. In fact, I could probably look at this, but it seems to be fine. In fact, no, that is something I need to do, which is return Lexer, or L. Okay, I think that's fine. I don't think we need to do anything else. I don't think I need to set char to null or anything. I suppose I could. I don't know if it would cause any harm. Okay, we'll do that just to be safe. I don't know if it will cause any harm, but we'll worry about that after. So L char equals null. Okay, I think we're fine. Okay, so that's it. So we've set the create Lexer function up. We've allocated a bit of memory for it, and we've set everything to null. Okay, so that's great. So that's up and running. Now this next function is going to be ReadChar, and after that we're probably going to end it this video there, and we'll pick up in the next one then. So we're going to return a Lexer for this one, although that doesn't sit well with me, but I think that's fine. Char. No, in fact, I don't think we're going to return anything for this. When I'm reading, the way I'm reading, I think we're going to take in the Lexer. So we'll do void again, because Go is backwards, and I haven't done any Go since the last time. The last time I done Go was actually when I read this book in the first place. So going over a year ago now. So I think we're going to take in the Lexer. So let's do that. Oh, that sounds about right to me. Okay. Right. So it's going to return nothing. Call it ReadChar. Lexer. We're taking in a pointer to a Lexer. Okay. We're going to say if the no, I could use just dot read position. That might actually be better. I know it's inconsistent, but for now we're just gonna do this. It just looks neater. Okay. I might change that after. That's probably gonna bother me, but it's fine. Right. So equals to is greater than or equal to the L dot input length. Then what we want to do is we want to set L dot char to equal 0. So it's effectively allowing us to read the first character in our array. Okay, sounds about right. So let's do the next bit then, which is if read position, well, if it's anything else, we're going to do l dot char is going to be equal to l dot input, and then we're going to do, okay, this is a, there we are. I was struggling to find where that was on my keyboard. Right, l dot read position. Now, I think what we're doing here, let me just finish it off, and I'll try and explain it as best I can. So l dot position is then going to be equal to l dot read position. Okay, I'm being sloppy here now. Missing out my semicolons. Again, it's a goism that's bothering me. L dot read position then is we're gonna increment that by 1. Let's try and explain that as best as I can then. Okay. Right, so what are we doing here? So we are messing things up because I got rid of my F. Right, okay, so we, Pete's sake. See, when it's just the LSP equals more harm than good sometimes. Anyway, right, so we're not returning anything back. We're taking in a Lexer. Or are we returning the Lexer and we're not taking in anything? Now I think about it. I don't know why that's bothering me. I don't know. That's bothering me, but we'll come back to that if it's wrong. Right, so we're not taking in anything. We're taking in Alexa, but we're not going to return anything. We're saying if l.read position is less than, greater than or equal to the input length, then l.char is set to 0, and otherwise, no, right, okay, no, that's wrong. What this is meant to be is the null terminator. Where is the slash? It's not that slash, it's backslash. Where is it? So my keyboard somewhere, there it is. Okay, so what we are trying to do is effectively say that if the read position is greater than or equal to the input length, then we want to return the null terminator, which is saying that we've ended the string. I forget that in Go that is 0, which is very confusing. I just so used to see it at the moment. So anyway, that's what we're doing there. Otherwise, what we're going to do is set l.char, which is a current character under examination, to l.read position, which initially will be 0 because we've set that up here. But as we call this again, what will happen is we're going to set the position to be equal to l.read position, and then we're going to increment then read position by 1. So it's effectively always going to be ahead of position. So we can use that then to peek char and see what's ahead. Now, I don't know if that's a good place to leave it at the moment. And I've just got my answer actually, looking over the next page. So what we're doing here is it makes sense. No, that doesn't make sense. No, I think what we done before was fine, right? Okay, not happy with that though. Okay, it's not happy with a lot of what I'm doing here, so let's have a little look at what's going wrong. Okay, it's to do with a few things. So that's one issue. Position. And it doesn't like the... Oops. So I guess I can't do that after all. Okay, I don't know. It doesn't like that either. Right, L position. Why is it doing that incompatible pointer? Right, okay, so we are just going to have to leave that then, I suppose. Okay, right. By the way, this video is very informal. If you prefer this, just me kind of programming, making projects, trying to type, then please let me know down below so I can actually continue to do it. But, you know, if you prefer more of a structured video, then that's fine. Okay. Nearly there. L reposition, or capital P for that. Y. And that as well. Okay, don't know. What? No member named position in structs. This is position. This is just polling. And again, I don't know why that is happening. Clearly I'm not. Oh, don't know what's happening there. Maybe I'm blaming it on the keyboard. Okay, for some reason I can't spell position, so sorry if you've been picking this up as I'm going along. Shocking. Anyway. Maybe is it because it's auto-correcting, but it can't be. I don't know. Okay. And then we're going to do the same W, and then we're done then. Okay, so I might tempted to leave it at that for this video. Because I don't think there's any more we can do in this particular part. Now, again, what I'm going to do is I'm going to leave a comment below to the GitHub repo that kind of inspired me to do it, or kind of supported me in doing it. Because I did run through this before. I did actually begin making this part 1 to this video earlier this week. But the issue that I had was I wasn't feeling well, and I thought that I wanted to make a good quality video and wanted to start, you know, effectively kind of do these projects more often, and I didn't want to kind of half-arse it, so to speak. So again, what we've done today then, what we've learned hopefully is nothing probably. No, we know where a Lexer is. We know, again, the header file is something we're going to look at for the start of the next video. Let's have a little look at what we got to do next, actually. I think now that we've done that, effectively we can use that to loop through. We're actually not far off. Believe it or not, this book is fantastic, and I would encourage you to read it. It's literally 35 pages long, which isn't, it's literally that long for creating a Lexer. So, you know, it's the easiest part probably of this whole book, because again, you're just breaking down tokens. But it's quite a fun project. You know, I've heard people say online, by people, I mean Michael Paulson, the Primogen, about, you know, how we use it to break down logs or something to that effect, which, I mean, makes sense. I mean, you could use it to, you know, I imagine, again, I don't know much about AI, it's not my expertise at all, but I imagine that you know, the word token is kind of used a lot with models like Claude. But I imagine it's just breaking down your input into tokens, and then it is doing something with those tokens that you've given it to effectively go on and do something with that. That's a very detailed breakdown of AI, but there for you. But no, that's, you know, again, I can see the use of this, you know, breaking down some sort of input into tokens and then doing something with those tokens. I mean, if you were to do in the language sense, of course, you're breaking down those tokens. You are, you know, using an abstract syntax tree. Again, you learn all of that in this book. You're building a Pratt parser in this book. It's really cool. And then effectively, you know, you can structure the way in which you want your language to work, which is quite neat. So it's very useful, and I would encourage you to look at that. But the next part is actually not that challenging. We simply need to create another function, which is going to ReadChar, I believe, or oh, sorry, no, we need to create a function which is called next token, which is effectively going to be a massive case statement, switch case statement, which is going to assign each token to a particular sort of input. And then the challenging part, which I guess we could do that pretty easy in the next video. The challenging part is going to be using Google Test, at least for me personally. Now, I've got this working earlier this week. I was playing around with it and I got it working with a lot of help from online documentation and even AI as well to kind of help get things up and running. But in that, we're also going to have to use CMake and things like that as well, which is something I've wanted to look into. We talked about make files in one of the recent videos, but that's something we're going to look at as well. So as always, if you've enjoyed, drop a like, comment, subscribe, and I'll see you guys as always in the next video. Thank you for watching, and bye.